Hello everyone, me Parth Bhandari
And I, Jagjot Singh,
are going to explain the further part of this project.
in which I'm going to explain the data pre-processing workflow. And in this project, to ensure the data quality, we have performed four key steps. First one being the encoding part, second, feature and target split, third, train and test split, and fourth one is the feature scaling. In encoding part, we have converted the categorical text data, for example, the M or F or the male or female, into a numerical format because it is easier for the machine learning model to understand it in a numerical or binary way, which is the 0 and 1. Second, in the feature and target split, we have separated the input features X from the target label Y, in which Y being are the predictions we want from the model. And third part, we have the train and test split, in which uh, in which all of the data set we are divided into two parts. First one being the train part, second being the test part. In the train part, we have used 80% of our data set to train the model, and in the test part, we have used the left 20% of the model to test how much our model is performing. And in the fourth part, which is the feature scaling part, we have standardized all feature values to bring them to a similar scale. Next, we have the methodology in which we have used first logistic regression.
Second is K nearest neighbors, which is KNN, and the third being decision tree.
So let me explain to you the logistic regression part. How it works is, in this model works by finding a linear boundary to separate two classes. It calculates the probability of an instance belonging to a disease or a healthy class. The sense of it are it is being fast, efficient, and the results are highly interpretable. Also, the accuracy of this model is 85.33%, which is actually very good.
So now I'll be walking you through the performance of other two models. Let's start with K nearest neighbors first. KNN is a very intuitive model that works like a voting system. When we want to predict the class of a new data point, the model looks at the 5 nearest neighbors in the training data set based on distance, usually Euclidean distance, and takes a majority vote to determine the class. This model is non-parametric. This implies that it doesn't make any assumptions about the data distribution. From the evaluation matrix and the calculation table in the slide, we can see that the KNN model achieved an accuracy of 85.33%, which is quite solid. Also, this table handles both positive and negative cases very well. Now, let's move forward towards decision tree. A decision tree works by creating a series of if-then rules based on feature values, essentially forming a flowchart-like structure. It splits the data step by step by asking the most informative questions at each node until it reaches a decision. One of the biggest strengths of the decision trees is the interpretability. For this model, we achieved an accuracy of 82.61%, though it is slightly lower than KNN, but it's still quite good. And it also shows strong performance in both positive and negative cases with high precision. Also, decision tree provides a very clear and understandable decision making path. Thank you.